Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Sorry if I get loud. In about 10 minutes, I kind of want to go through the philosophy of this project that I started several years ago with my colleagues, of course, and show you some demos and also then show you some of the newest stuff that's hot off the press. Even just last night in the hotel room, I just rendered some of the images. So we'll see if it works. So first of all, the philosophy. Let's just go a few slideshow. I'm actually going to demo, but just go through a few of these. This is one of our central philosophies. I always put this up in in a lot of my talks because it really drives a lot of the stuff that we're doing. We think that scholarship is about the flow of ideas and the things that we're good at, which are networks and thinking about networks, the mathematics, the visualization. Networks are all about the flow of information. So what do I mean by flow of information? So one of the things that you can find at Eigenfactor, we have all sorts of different things. We're adding stuff all the time. We take things down. We're going through a major update. We're just kind of a little research lab, plays around with stuff. But what I mean by flow, what you're looking at here, for those who haven't seen our radial diagram, on the outside of the ring are the major fields of science. From a large data set, this is about 6 million citations in about 8,000 journals. So I can click on physics, and I can look at the flow of information between different fields of science. So we're actually summing both the in and out. We're just, the underlying data here is citations. But you can actually zoom into individual journals. I always like mathematics. It's close to my heart. So if you click on a mathematics journal, you can see the fields and also the journals in which there is this flow of information. And with this particular sort of demonstration of what the flow is, you can apply this to any data. You can apply it to not just scholarly literature, but we play with other sites of data, like we're working with the flow of money in the federal banks and all sorts of other data sets. But the point is, we're trying to track this. And the interesting things are also where they're not flowing. I always find this interesting. But you can kind of play around with that. So what we're kind of known for, is when we first started was we built a tool for librarians and scholars, of course, to try to evaluate journals. So you know, here I'll just pull up, let's say, ecology, since that's my field. The web connection's a little slow, but whoops, it's wanting me to do this. So turn off. I'll try this trick. Actually, I may even just, yeah, it just keeps hitting me off. Okay. Okay, it keeps wanting to flip me. Okay, get off of there. Yeah, I know. How about I forget it so much I turn it off and click hard right in here. I don't want to waste time because I have too much things to show. Okay, let's try it here again. Do you see something? Do you see something? All right, it doesn't see. Okay. Turn back on. Yeah, I'm going to join the Cambridge here. Come on, come on, come on. Okay. Okay, now we're back on. Okay. Slow as molasses, but okay. All right, so let's go back here. We search. You can search a journal. Let's go back to ecology. So, you know, you can find all sorts of journals. We're actually working with SSRN and other groups where you got article level metrics. You can click on individually these journals. One of the things I've kind of found interesting with looking at this kind of data is, you know, we can track, you know, the influence within the scholarly literature through citations, and we have these time graphs. You got these article influence scores and these Eigenfactor scores. But the economics is really interesting. So when we talk about the future of scholarly communication, I'm wondering if we're going to have this conversation 10 years from now about the economics. And we're working with a lot of librarians that really are using this pricing information. But I don't really want to talk so much about that. What I do want to do, I thought, when you're trying to show people in 10 minutes what you do, I thought it would be good to give you a problem to try to think about. I've shown I've done different demonstrations of different algorithms we've designed. This one I've never really shown, and it's a lecture it's an entire lecture I'm going to do in like 2 minutes. So all I want you to do is look at two things. I want you to look at this number down here. We call it the description length of the network we're trying to describe. And all I want you to do, so all you're doing is looking at that. I'm going to change all these to the same color. And what I want you to do is use your pattern recognition in your brain to try to see what are the modules here in this network. There's about 25 nodes there. So, and what you'll see is that this particular description is a little bit higher than what you saw before. Oh, whoops, sorry. That was hanging on the, there we go, technical difficulties. Okay, so, so now what I want you to do is I'm going to take a different color. And I'm going to say, you know, my pattern recognition says that's a cluster. So in doing that, don't worry about what's all going on. You don't have time to figure that out. All I want you to know is that this is going down. So let's use a different color. Let's go red, and let's get another group. Up, the description went down. Basically, this is an entire field of, of research, which is called community detection, trying to figure out what the groups are in large data sets. When you're at this sort of scale, of course, you can kind of pick it out yourself and you don't need it, and I'll optimize it so you see what the optimal code is. You see this, which is always interesting. This one pops out as a group. The thing that I'm trying to get at is we work with big data sets, including the scholarly literature, which is my favorite data set to work with, and we do things like this to build maps so that it can help scholars better navigate the scholarly literature. We do it to try to understand communication in all sorts of different data sets. But what can we do with this? And so we've, like I said, we've worked with lots of different data sets. Microsoft Academic Search has been super kind in sharing their data in their Microsoft Academic Search API. And one of the things, using this same kind of problem that I showed you, there's a lot of different things we do. We recommend. We have a recommendation system, the mapping, exploring. We have this new navigator. But I'm just going to show you just a couple things real quick. So looking at, this is a small subset of their data set, but this is 1.7 million papers compressed. It uses a similar algorithm and goes through and compresses, and then it outputs. You know, if we use full text, we can also get labels. And we see in this subset, it's obviously a computer science subset, you can see the flow of ideas between these different fields that the data set's representing. You can also go, let's say you're interested in computer science theory, and you want to click in. You can double-click it, and here are authors. In this case, it's journals. You can look at who are what are the top papers or journals in that particular field. And also, let's say you want to increase the flow. You want to see more of the flow that's going through this data set. As you do that, and you increase the flow, you start to see symbolic logic and some of these other fields pop in. But I start as a default something that's a little bit smaller. So this is the sort of dynamic map that you can play with in your own field and on any data set. It's something you can actually do on your desktop, and you can get these sort of visualizations of exploring your data. So then there's one other thing I'll show you before I kind of wrap it up, is our recommendation system. So one of the things we're kind of excited about is we talk about maps all the time. They're a way of kind of getting a 30,000-foot view of the landscape of science. But what if you need a compass? The future scholar may need a compass too. So the compass is this recommendation system. There's lots of recommendation systems. This is just our own sort of thing we're playing with, and surprisingly the results so far have been pretty darn good. I mean, it's not perfect, but let's say you were interested in Kleinberg. You've read his authoritative sources in hyperlinked environment, and you're a graduate student. You've never really read the field. We have a recommendation for you based on the mapping equation and the Eigenfactor algorithm that says, here's a classic paper you should be reading if you're brand new to the field. If you're an expert in the field, maybe you should read this paper. It's an expert recommendation. And then we have two others. We have a hot one if you're interested in the most recent things in this particular subfield. And then we have various other things. But the point is, we can use this mapping approach to give you clues. And so far, the results have been good. They're not all been good. We've shown a few of our economist friends, and they're like, come on, that's terrible. And we get some of those results, too, sometimes. But this is kind of the main questions that we're getting at. How can we better evaluate the scholarly literature, knowing what we know in this particular field? And also, how can we better navigate? So these are the sorts of main questions we're getting at. And here's one more sort of challenge. I gave you a challenge before about trying to figure out groups. Here's one of the maps these are two maps at two different time points. And what we're trying to do with these two different, by looking at these things, is try to figure out what's changed in these different time periods. We want to know what's going on over time. So some of you may have seen our alluvial diagrams. Basically, you take one of those maps at a particular time period, and you compress it. So this is molecular and cellular biology. This is oncology, psychiatry. And what you find are some really interesting results, of course, if you look over time. What you see in the last decade, and we've talked to the neuroscience field, that you get the formation of a standalone field, neuroscience. And we can do this on other sorts of data. And then the last thing, this is the last thing, there's actually two things that are hot press. I'll just show you the one. We're also interested in, when we talk about scholarly communication, we want to know what the jargon barriers are between fields. There are citations and flow, we know that, but what are the jargon barriers? So we now take full text data. This is one of the first maps we've produced, which is an actual topological map that shows groupings of areas, and the height is the actual jargon barrier. It's a measurement of the semantic distance between your two different fields. And I can show you, we're really excited about this. This is really showing us a lot of neat stuff. And that's, I won't show you the results, but that's it. We're interested in information flow. We have lots of different tools, and that's how I'm going to end. Thanks.